Hello, hello, hello. I hope I'm audible. Good evening, everyone. Okay, so let's start today's session. So, welcome one of you. I'm Karthik Jadhav, a research scholar in the Department of WRDM IT Roorkee. So, we are currently uh, learning about soil science and technology. So basically, this course is run by Professor Chakrabarti from Department of AGFE, IT Kharagpur, and I am a research fellow uh, at IIT Roorkee and working as a prime research fellow in this department. So these are the general information about me. If you have any query related to this subject, you can directly reach me out to this provided email ID by putting soil science and technologies as a subject, and I will try to return my your emails within 24 hours during working days. I also want to uh, say that all the contents. Hi Abhinaya. Yeah. So whatever content I'm covering since past 10 weeks and whatever I'm going to cover that I'm uploading in this YouTube channel, you can scan this QR code and also click this link to get that content. And all the lecture materials in the PDF format I'm uploading in this Google Drive format. You can easily access it. I also request you to provide your valuable feedback for this course so I can further improve on this based on your feedback. Okay, so currently we are at week number 11, and in this week, basically, we are focused on GIS and GPS application in soil science and technology, and its fundamental concept, specifically focus on the geostatistics, and also discuss basic of diffuse reflectance spectroscopy for soil. Now, before we begin, let me quickly summarize the content of week number 10. So, in week number 10, we have basically focused on the remediation of organic and inorganic contaminants in the soil. So, we have discussed various physical, chemical, and biological methods. And specifically, we have focused on the phytoremediation, various techniques. And then we have discussed how this remediation techniques gets evolved and nowadays how scientists and researchers are only focusing on the sustainable resilient remediation technologies that includes all the primary, secondary, tertiary as well as climate change impacts in the solution like in this case we are focusing on soil or polluted soil remediation techniques. Then we have discussed about important concept related to the life cycle assessment. So that is also important nowadays because it is one of the most integrated quantitative methods to quantify environmental impact associated with the remediation techniques. And then we have started talking about what kind of materials we can use to remediate the soil. So then we have identified that surfactants and organoclays are very important and it plays a role in situ as well as ex situ remediation treatments and that will generally enhance the biology of the contaminants for bioremediation. or chemical treatments. And the basic difference in both of these are that the nature of surfactants are amphiphilic organic compounds. So amphiphilic means it is hydrophobic as well as hydrophilic in nature, while organoclays are modified nature of clays and that have a higher cation exchange capacity. And in terms of mechanism, if we can say, so whatever contaminants that attach in the soils, so that when we are adding surfactants to the soil, that polluted soil, what is happening? So that surfactants help us to get mobilize or solubilize that contaminants, okay, harmful contaminants. While once it get mobilized or solubilized in the soil water solution, and if we are adding organoclays after that, then that pollutants get adsorbed or immobilized in the polluted soil. And generally, this surfactant is best for flushing and removing of contaminants, while organoclase is binding and stabilizing the contaminants. And then, we have already discussed flushing about and stabilizing of particular contaminants. Then we have also talked about biostimulation and bioaugmentation. So in stimulation, we are just adding enrichment medium, while in case of bioaugmentation, we are adding exogenous urolytic bacterial culture to remediate the soil. Then we have also discussed about the aging effects. So aging generally in soil remediation, in terms of soil remediation, refers to the physical, chemical, and biological changes that contaminants undergo after being introduced into the soil over the time, right? It is but obvious that whatever we are adding in anywhere, not in the only soil, its concentration gets reduced over the time due to the various biological, chemical, and physical activities. And then we have learned important concept related to the bioavailability and total concentration. So what is bioavailability? So bioavailability generally refers to the fraction that is accessible to living organisms such as plants, microbes, or animals. While total concentration is refers to the entire amount of contaminant present in the soil. And then that's why whenever we are building some remediation techniques or designing some remediation techniques, what we are doing, we are considering the bioavailable amount of particular contaminants, because that bioavailable contaminants only harmful for the humans, plants, microbes, and animals. That's why risk assessment must consider how long contaminant has been in the soil and how tightly it bound, considering its bioavailability. Then we have started talking about the main mechanism of phytoremediation. So phytoremediation, we have considered total five phytoremediation mechanism. So first one is a phyto extraction, then phytostabilization, phytodegradation, phytovolatilization, and rhizodegradation. Okay. After that, finally, we have started talking about the what is remediation and how we can control it. So there are some few certain strategies, and that mainly classified as either we need to control the source of that particular contaminants, then reduce its immobilization, and removal and contamination using various chemical, physical, and biological methods. And then finally, we have started talking about soil survey and planning. So there are various type of surveys are available, and at different scale, we have a different soil survey, and that we have discussed in detail that what we need to consider, like how what are the physical properties, what are the chemical properties, or what are the biological properties that we are considering in the soil survey, like how detailed we are preparing that survey report, and that survey report ultimately we are transferring that to the remote sensing data. Okay, and that we have focused on this upcoming week number 11. So before that, let me quickly also revise that we identified in phytoremediation there are certain plant species that we are generally using. So that are first one is a sensitive plants, then indicator plants, excluder plants and hyperaccumulator plants. So sensitive plants so that absorb metals but cannot tolerate them, right? So in case of sensitive plants, it is only sensible to particular metal. Okay, but it is if its concentration gets increased, that will directly impact its growth and that will not sustain against that higher metal concentration. While in case of indicator plant, it uptake the metals, then that proportional to the soil availability. Okay, and it survive across the range of concentration, but do not accumulate excess metal, useful for monitoring contamination level. Okay, as it is not uh, uptaking or accumulating the excess metal. Okay, it is only up to the certain levels. So that's why it is only used for monitoring of contamination for certain levels. Okay, but obvious. And while third one is excluder plants. So excluder plants that is highly tolerate to contaminants and restricting metal uptake. However, metal remains in the root zone only. Okay, and we cannot remove them from the shoot. While the hyperaccumulative plants, so that actively extract and accumulate the high metal concentration, it's also move the metals to the above ground. So that is its main advantage. That's why generally nowadays we are considering hyperaccumulative plants. And then we finally, as I said, that after soil survey lecture, we have talked about various type of soil survey, its objective of soil survey in soil science and technology, and then basic steps we need to follow. And then once we have the soil survey data for various locations, then how we can use the data to prepare geographical layers. Okay, basically GIS layer. And then we'll talk about detail in this upcoming week. So in week number 11, we have started with the talking about the GIS, that is Geographical Information System. And then we have identified that in GIS system, I'm not going into detail. So this is the framework of the GIS system, and you can see whenever we are importing data into GIS software, then uh, that data input generally in the form of database, so that either it is a vector or raster, and then that geographic database, and that we are using for our aim. Okay, because from one data we can correlate it with the various uses, and then uh, so based on our objective we are providing query input in this geographic database, and then ultimately that query that will we are providing or we are doing by our own self, that will help us to provide desired output. So generally, two fundamental types of data models are there in GIS. So one is a vector data and second is a raster data. So vector data is a series of XY coordinates, and for discrete data it is represented as a point, line and polygon. Okay. So whenever suppose point data, what is a point data? Point data is any data. Suppose you want to uh, highlight the data of certain school, okay, hospital, then your home, so that all are point data. Okay, while lines, in case of lines, we are lines data are like roads, or you can say rivers, while polygons uh, are related to the are related to the lakes, small water bodies, right? That's why to represent that physical feature that is available on the Earth surface, we are using generally vector data. While in case of raster data, so that represented as a grid and cell. Okay, so raster data is available in the form of grid. Okay, and that each and that all grids have cells. So that cells have a uh, predefined size. Okay, and that we are generally using for continuous data. And what is continuous data? So that is either elevation, slope, or also we are using for rainfall data because it is varying spatially. Okay. Then we have started learning about GIS model example. So if you can see from this figure, so here we have a three layers or themes. So first one is a roads, then we have hydrology and topography. So they can be related to because precise geographic coordinates are recorded for each theme, right? So if you can see here that whatever we are representing on the geophysic or on the spatial data, that we are representing as a latitude and longitude. Okay, so based on that latitude and longitude, you can able to identify particular exact location on the map, and that will help us to draw certain analysis based on our objective. Then we have also shown that various terminologies that are important in the ArcGIS or GIS and remote sensing area. So first one is the projection. So that projection is the method of converting Earth's curves 3D surface to flat 2D map using XY coordinates. And its example are we are generally using UTM. That UTM is Universal Transverse Mercator. Okay, and that UTM projection are we are generally using, okay, when we are transferring our data from geographical information geographic coordinate system to projected coordinate system. Then we have scale. So scale is generally ratio of distance on the map to the actual ground distance. So whatever at scale, suppose if we want to show India on the GIS layer, then we need to we cannot use that big area. Okay, so we are transferring that big area into this small representation that we can show that we can see on our desktop. Okay, so that what we are doing, we are scaling down something to represent it on a map. That is we are showing in seeing in our RGS software at the desktop. Then accuracy. So accuracy is about how well spatial data matches reality. So there are three steps in that. So uh, positional accuracy, it means how close are the map features to their real world locations. Okay, because whatever data we are collecting on field, that is it is not like that that is at of the exact location. Okay, that's why estimation of the positional accuracy is very important. Then we have a consistency. So are attribute data like soil type, land use consistent with the field reality, right? Because consistency is very important. We cannot see even the accuracy is more. We cannot say that it is a consistent. Okay, because at certain location it representing well or it is working better, but at certain location like hilly area we have identified certain problems. That's why consistency is very important in a plain area as well as high altitude area. Then we have a completeness. So that does that's generally it does the database contain all the real world feature. Okay, and its example are all the erosion prone spots marked in the soil erosion map. Means how we are identifying erosion map, erosion prone spots. So as we have discussed that erosion is a function of RKLSCP, right? So we are collecting all this data, then we are using Usle equation to identify erosion prone zone, okay, based on our fundamental understanding. And then we are mapping erosion prone area. And now the erosion, it is not like that whatever we have predicted through the to the Usle equation or Rusle equation or modified Usle equation, that is not correct, that is as available on the field. That's why This completeness is measured it. Then we have also talked about the spatial and attribute data. So spatial data is generally provide information about where we are where that particular features are there, and attribute data that provides its location uh, features. Okay, like either it is a rainfall, soil type, whether it is a altitude or temperature, humidity, whatever parameter you can say that we can add for that particular location. Then there are certain queries that we are generally using, like join, to combine this data. Then we have also talked about application of GIS software in soil science. So there are various type of users that are available and they are using the softwares. So generally in soil science, we are using for mapping the soil fertility zones, monitoring land degradation and erosion, assessing the contamination spread, and creating land use planning maps for sustainable agriculture. And then in continuation with that, we have started talking about this GPS, that is the Global Positioning System. So it is a satellite-based navigation system providing accurate location data everywhere on the Earth. And it's generally used in soil studies for making soil sampling points. So whenever you are going on the field, we are taking GPS location because we need to present, okay, where from where we have took this soil sample, right? Because you know that the nature is a very complex, and even if you can measure the soil properties at two nearby place, even of the 1 meter distance, that may also contains huge variation. So that's why uh, get taking down of exact location of that uh, sampling point is a very crucial while we are assessing the soil physical, chemical, or biological properties. Then that will also help us to tracking field operation, like from like based on our field observation, we can create certain models that will help us to decide where we need to apply fertilizer and where we need to carry out tillage operations. Then it will also help us in integrating GIS to produce geo-referenced map for future studies. In general, satellite geometry is explained as a good geometry and poor geometry. So good geometry is when the satellites are widely spaced and triangular your position with minimal error. While poor geometry is when satellites are clustered or aligned, that causing higher uncertainty. And how does this GPS is working? So in GPS, basically we have a GPS receiver that picks up signals from at least four satellites. So for to work GPS better, we need minimum four satellites. So whenever you are on Earth and we are and for example for your mobile, whenever you are turning on your location, so what is happening? This GPS, we are generally GPS receiver. Okay, whenever you will turn on this location, so this GPS receiver that we have in phone that picks up signal from at least four satellites, and we know that each satellite sends its and whenever this gets location gets on, this each satellite sends its position and exact time, and based on that, receiver calculates its distance from the each satellite using time delay. Okay, and using this distance it triangulates the exact location. Okay, for example we are here, and once we are on our location, so that sends to four satellites that is nearby. Okay, and then this satellites sends the exact time and position of that satellite, and based on that uh, data, this receiver calculates its exact position by triangular principle. Okay, but there are certain source of errors in GPS. So in GPS generally, we have fundamental problems due to satellite clock errors. Okay, right? Because it's satellite is sending its time. So slight timing errors from onboard automatic clocks. So that generally leads to the poor location. And if you observe that, yes, in certain areas like hilly areas, whenever we are going there, the once there or where satellite is not accessible, at that time that GPS signal gets lost. Okay, due to various issues. And also if we can talk about the accuracy of GPS, that is also around earlier, since we can talk about before 10 years. At that time we have a poor location, like we have the accuracy of around 10 meter, 5 meter, but currently we are getting it at 1 meter level. Then second one is a receiver clock bias. So cheaper GPS units have a less precise clock. So based on the GPS system we have it on our hand, that also matters, uh, or that also major concern is source of GPS error. Then atmospheric distortion. So we know that in atmosphere nowadays, various gases like greenhouse gases, then at certain times there is a precipitation, extreme precipitation that is happening, and that all cause the errors in GPS system. Then orbital error, so deviation in the predicted satellite's orbits. Okay, so whenever this kind of things is happening with satellite, that also cause the source error in GPS. Then fifth one is a receiver quality. So better quality, better the accuracy. Okay. Then multipath error. So signals bouncing off buildings or trees can confuse the receivers. Okay. So that diagrams we have discussed during our lecture number 52. That due to the presence of trees and buildings, so that whatever reflectance is going back from that, that also confuse the satellites. Then satellite geometry. So poor satellite positioning reduce the accuracy. That we know that we have discussed here. And selective availability. So international signals scrambling by US Department of Defense, that are disabled in 2000. That also matters to the source of GPS. And then we have started talking about geostatistics. So geostatistics is a subset of statistics that deals with analysis and prediction of spatial reference data. It is particularly useful in a soil fertility mapping, environmental contamination assessment, precision agriculture, and groundwater modeling. And if we can talk about why geostatistics is important, so traditional mapping methods often rely on a subjective judgment and mental models. Okay, while geostatistics offer data-driven, objective approach to produce spatial maps by reducing the need of dense sampling, estimating unknown values at unsampled location, providing uncertainty assessments for predictions. And uh, these are the certain questions that we are addressing by learning geostatistics. So, how does a variable vary in space? Then what controls its variation in space? Where to locate samples describe its spatial variability. How many samples are needed to represent its spatial variability, and what is the value of variables at some location? And then finally about uncertainty of the estimates that needs to be computed. And these are the steps for understanding the variability. So variability is generally sum of deterministic, stochastic, and noise. So deterministic is about the predictable patterns that we are generally predicting through various physical formulas or concepts, while stochastics stochastic variability are random in nature. but it is structured. Okay, and then noise, that is a pure measurement errors by observer. And in step 2, what we are doing, modeling variation. So geographical 2D or vertical 3D layers use models like discrete model, continuous model, and mixed model. So in context of GIS and statistics, blue, that is the best linear unbiased estimators, refers to the estimator that is linear, unbiased, and has the smallest variance among all linear unbiased estimators. And it is often used in a regression analysis and spatial modeling. So let's understand this blue. So what is unbiased? So unbiased expected value of estimators equals to the true value of parameter being estimated. While linear, so the estimator is a linear combination of observed data, and best, that it means minimum variance. So among all linear unbiased estimators, blue has the smallest variance, meaning it provides most precise estimate. And Gauss-Markov theorem. So this theorem states that under certain conditions, the ordinary least square OLS estimator is a blue. And then we have started talking about basics of visible near infrared DRS. So before that, we have started talking about spatial prediction models, so that are divided into two types. So that is mechanical and or empirical models, and statistical or probabilistic model. So empirical or mechanical model. So this model don't assume underlying statistical distribution. Okay, so it is not about statistical distribution. So they use geometrical or mathematical methods. For example, Thyssen polygon. So it assign values to unsampled point based on nearest measured point. Second one, inverse distance interpolation. So closer points influence the predicted values more as compared to the distant one. And that inverse distance approach that we are using, regression on coordinates. So fits the regression line based on the spatial coordinates. And splines, so fits as smooth surface through simple points. So all these techniques have their own use. For example, in case of generally for certain parameters like rainfall, we are generally using Thyssen polygon or IDW methods, and based on the accuracy that we want. If you want to just consider a simple approach, then you can go with the Thyssen polygon approach. Then if you want to go in detail, then you are going with the IDW approach. Okay, like that. Then in case of statistical or probability models, so they are rely on statistical theory instead of any instead of any mechanical or empirical formulas. And example of statistical models are Kriging. So it accounts both distance and spatial photo correlation. Okay. While environmental correlation, so it uses covariate covariates like elevation or vegetation. Then based models, so it incorporate prior probabilities. While regression kriging combines regression and kriging for better accuracy. And now let's talk about krigings, as it is the most powerful geostatistical interpolation technique and developed in a mining 1950s, now widely used in soil science and environmental mapping. It provides best linear unbiased prediction of values at unsampled location. And then we have also talked about variogram. So variogram is a core tool in geostatistics describing how spatial correlation decreases with the distance. And its if you can talk about its components, then it is a gamma edge, that is semi-variance for distance edge. Then we have a nugget, that is small scale variation or measurement error. Okay. Then sill, that is a maximum variance, and plateau level of variogram. And last one is a range, and range is distance beyond which samples are not correlated. It is important because it helps to determine the weights in a kriging and tell you how far spatial correlation extend in your dataset. While, or we can say in summary, IDWD method is a very simple, fast, and generally using for mapping, while kriging are more accurate and used when spatial autocorrelation matter. Okay, so whenever there is, if you feels like there is a autocorrelation in your spatial data, okay, like contamination in soil, contamination in your water resources, okay, that time it is important to use techniques like kriging, while variogram, that is the basic for kriging and that helps to understand spatial variability. These are the widely used applied in precision agriculture, soil fertility mapping, and contamination study. And then in lecture number 54, we have again talk about the basic of visible near-infrared DRS, that is diffuse reflectance spectroscopy. So this technique, diffuse reflectance spectroscopy, is a fast, cost-effective, and needs minimum or no sample pre-treatments. Also, it is high throughout and non-invasive and portable in nature. It helps us to measure estimate parameters such as organic carbon, available nitrogen, phosphorus and potassium, pH and clay, and moisture and heavy metal content in our soil using certain lights. So there are generally, you can see here, there are specular and diffuse reflection. So specular reflection is, it is like a mirror and from a smooth surface, while diffuse reflection scattered in a multiple directions due to surface roughness, typically soil. So from soil we are generally receiving diffuse reflection. And if you can see that how diffuse reflectance works, so whenever there is a white light from sun will come and strike on soil materials, it gets back reflected. Okay, and this reflected are scattered in multiple direction due to soil surface roughness. And in sunrise, we know that there is also visible light as well as near infrared light. So visible light have a wavelength of 350 to 700 nanometer, while near infrared have 700 to 2500 nanometer. And there are certain basics like visible and near infrared diffuse reflectance. Spectroscopy is a technology that uses mug light or contact probe to produce reflection at different wavelengths. So in this range, visible and near infrared range, this instrument, that is DRS, diffuse reflectance spectroscopy, uses Merc light or contact probe to produce reflection at different wavelengths. And this is this instrument is in the form of field probe. Okay, it is a portable in nature, simple, and reflectance pattern can be correlated to number of soil properties. You can see this chart. So this is visible region, and below this it is infrared region. And infrared region have a near infrared, mid infrared, and far infrared. And then lastly, we have finished this week content with talking about the PXRF. So PXRF stands for Portable X-ray Fluorescence, right? So it is a non-destructive analytical technique used to identify and quantify elemental position in soil and other materials. And its key features like a battery operated handheld device such as Olympus and Vanta operate at 10 to 40 watt, and then it's required certain internal calibration to ensure its accuracy based on the knowledge energy known energy emissions. So this is the instrument that we'll discuss soon. So use silicon drift detectors (SDD) for light element detection. Okay. Then it's operated in geochem mode, optimized for soil testing using normalization algorithms, and it's also tuned to detect lighter elements like calcium, potassium, sulfur, phosphorus, and chlorine. And if you can see this figure, that this is the instrument. So it the instrument have the source of X-ray, so that emits the X-ray radiation. So whenever it's get emits, it strike on particular uh, targeted element, and that X-ray get reflected back. And here we have a detector. So the detector we are using to detect that reflected back X-ray, and then generally we are using that reflected rays in the processor and processing with the CPU, and that CPU generally converts transfer that data on monitor. And there we can use this signal content that have some value, so that get processed to some formula, and we can get generally targeted element concentration. And XRPF PXRF configuration. So again, what is PXRF? That is potential X-ray fluorescence. Okay. So this section explain working principle of PXRF using atomic electron transition and X-ray fluorescence theory. So whenever primary X-ray hits an atom, as I describe here, it ejects an inner cell electrons. An outer cell electron drops down to fill the vacancy, releasing energy in the form of characteristics of X-ray fluorescence. Okay, and these are the its fundamental, and we are generally using Planck's law. Okay, while converting these signals into the concentration. So Planck's law is, we know that it is E is equal to h mu E. Okay, where E is the released energy of emitted radiation to the its frequency. And there are certain advantages of this, like it have a field portability, so it can be used on site. No consumables are required, or also no reagents are needed. It's simultaneously multiple element detection. We can do that, and generally it have 20 to 30 elements detection technique, and it is rapid scanning times around, it's taking 60 to 90 seconds per sample. Okay, that's why it is very important, because in other cases or other instruments, what is happening, that instrument uses taking too much of time to estimate that particular element, right? While this this PXRF is a field portable instrument, so we can carry out that on a field, or we can take that on a field, and by just putting some button, we can emit the X-ray, then uh, calculating its reflections from element, and to measure the certain elements like calcium, potassium, sulfur, phosphorus, and chlorine. So it is very important to use such techniques. And finally, we have talk about potential soil application for PXRF. So its application in textural determination, then it also help us to identify pH, salinity, cation exchange capacity, then base saturation percentage, plant association elements, mineralogy, and it have advantage of it is a non-destructive. Okay, because in case of other traditional approaches, what we are doing, if you want to measure something for this soil, we are just taking soil samples from one location. Okay, So what we are doing, we are using some certain agars or core to get that sample, and that sample we are transferring to laboratory. Then we are adding certain preservatives to uh, preserve that particular targeted contaminants if we are not doing analysis immediately. And then also in the analysis we cannot directly measure certain element concentration on the soil. For that we have various extraction techniques for individual compounds, so that we are doing. And then that extracted samples that we are putting on heavily cost machine that require reagents, standards to run it, also power consumption. Okay, so that's why uh, the techniques like PXRF, that is a non-destructive and rapid technique, so that provide multiple element at multiple location on same farm or same watershed, and it low emits the detection and wide dynamic range. While it have certain disadvantages like there is no HC or Na, okay, and there is a moisture effects on its working, and soil heterogeneity is the major problem. Then we have also discussed earlier application of this instrument PXRF on the cation action capacity, soil pH, then on the different kind of soil like urban peri-urban soil, and then we have discussed finally fusion of PXRF and DRS. So with that, we have concluded that week number 11. And till now, if you have any query, let's quickly ask that so we can take few query. Anyone? Okay. Satwara, anyone? Okay. If you do not have any query, let's take few minutes break here, and then we'll rejoin and uh, again start talking about. We'll solve certain multiple choice questions. And in between, if you have any query, you can directly ask me by writing in the chat box. Okay, so we'll be there after 5 to 10 minutes. यार ना ये बोल लेट okay. Hello. Okay, welcome back friends. Let's solve using questions. Okay, so question number one. Question number one. Spatial variability is dependent on deterministic process, stochastic process, pure noise, and D all of the above. So we know that deterministic process, stochastic process, and pure noise combinedly represent the spatial variability, right? And specifically, deterministic process where spatial variability arises due to the known causes like slow parent material, land use, or vegetation. The patterns are predictable if the influencing variables are known. While stochastic process, this involve random variation that cannot be fully explained by known factors. They reflect inherent natural randomness in soil properties such as minor variations in texture, moisture, or nutrient levels. While pure noise, this refers to the variability that is completely unpredictable and random in nature, and that is possibly due to the measurement errors, as well as instrumental noise that is unknown to us, that adds uncertainty to spatial data set. So, all of the above are the correct answer for this question number one. Question number two, spatial prediction models can be statistical or empirical. Which of the following is an empirical model? So we know that among these, Bayesian polygon, Bayesian models, Kriging. So Bayesian model and Kriging are the part of statistical model, right? While Bayesian polygon is empirical model because that assigns value to unsampled location based on the nearest sample point. It creates non-overlapping polygons around each sample location. Okay. And it does not involve statistical modeling that makes it purely empirical. So correct answer is option number A. While the Bayesian models refers to the statistical prediction model, and that incorporate prior knowledge or beliefs and update them with observed data using Bayesian theorem. And these are the probabilistic and non-empirical in nature. While kriging is also geostatistical method that use spatial autocorrelation and variogram to predict the values at unsampled location. It is a statistical interpolation technique that maximize predictions error variance. So option A is correct answer. That is empirical model. Question number 3. In inverse distance interpolation technique, ensure an unbiased interpolator, the sum of weights needs to be equal to 1, 0, infinity or minus 1. So we know that the sum of weights needs to be 1, right? Yeah. Yeah. So inward distance interpolation technique, the sum of weights needs to be equal to 1, right? Because each point is assigned a weight inversely proportional to its distance from the unknown point. To ensure the interpolated value is unbiased, the sum of weight must be normalized to 1. That ensures the weighted average is a mathematically consistent and meaningful. So correct answer for this is option A. Question number 4. In a variogram, nugget implies, so you can say nugget. So maximum, option A, maximum distance at which data are correlated. No, that is not correct. The distance over which data are absolutely corrected or unsampled. So it seems to be right option. Maximum variance of data, that's also known, none also. So correct answer is option B. That distance over which data are absolutely correlated or unsampled. So the nugget represent the variability at very small separation distance, often due to the measurement errors or micro scale variability, and it includes or it indicates the data points that are very close still may not exactly the same due to the noise or sampling limits. Question number 5. Diffuse reflectance spectroscopy can be used for which of the following parameters? So option A, organic carbon, B, moisture, C, available nitrogen, and D, all of the above. So we know that diffuse reflectance spectroscopy can be used for all of to measure all of these parameters. And in case of organic carbon, DRS is an effective for assessing it in the soil, as organic carbon has a distinct spectral signature in the visible and near infrared region, making it detectable using diffusive refractance spectroscopy. While moisture affects the reflectance, especially in near infrared range, DRS can estimate moisture content based on absorption patterns of water molecules in the soil. While available nitrogen, although it is indirect, so DRS can be calibrated to estimate available nitrogen in the soil, particularly in correlating spectral patterns with nitrogen concentration using statistical models. The correct answer is option D. Question number 6. Modes of vibration in mid-infrared regions are, so we know that molecular rotations typically occur in far infrared region, not in mid-infrared region. Okay, so molecular rotation is the correct answer. Well, uh, fundamental molecular vibration. So that we know that that is in occur in MIR region, that is mid-infrared region. Mainly detects fundamental molecular vibration such as bond stretching and bending. This vibration gives rise to characteristics absorption bands that are widely used for chemical identification. Okay. Well, third one, that is overstone and combination of bonds of fundamental molecular vibration. So this occur in near infrared region, not in mid infrared region. So correct answer is option B. Question number 7. What is the use of spectralon panel in spectroscopy? So we know that a spectralon panel in spectroscopy that removes ambient temperature effect. So while spectralon panels themselves do not actively control temperature, using during calibration can help to normalize spectral readings and minimize the indirect effects of ambient temperature fluctuation. It removes the humidity effects also. Similarly to the spectralon doesn't remove humidity per directly, it helps to maintain consistent reflectance standards, which can reduce variability in measurement due to atmospheric moisture. It also optimizes the spectrometer. So the primary function of spectral on panel is to optimize the spectrometer. It acts as a wide reference with near perfect reflectance that helps to calibrate the spectrometer. And so D option is all of the above. So correct answer is option D. Right. So all of the above is use of spectralon panel. Question number 8 in PXRF. Okay, that is portable X-ray fluorescence. The scanning time for scanning time of a given sample is typically around. We know that it is around 60 to 90 seconds, and it is a minimal, right? So if you can see here, this portable XRP, P, XPRF, basically portable X-ray fluorescence. So samples and it is sending, then again back detecting, so that will help us providing some graph sizes, and that we are ultimately converting that into the some signature that gives us concentration. And in this case, the typical time is around 60 to 97 seconds, and this range balance the signal strength and analysis time effectively and ensures better elemental resolution and repeatability. So correct answer is option C. Question number 9. PXRF can be used for measurement of which of the following parameters? We know that portable X-ray that can help us to measure electrical conductivity, cation exchange capacity, as well as micronutrients. So all of the above are the correct answer for XRF. And electric conductivity generally do not directly measure but can estimate salinated elements like sodium, fluorine, and sulfur, which contributes to electrical conductivity. While cation exchange capacity, again, it measures elements like calcium, magnesium, sodium, and which are exchangeable cations that help us to estimate cation exchange capacity. Well, micronutrients or micronutrients like NPK as well as certain heavy metals like iron, zinc, copper, manganese that also help us. Also, we can estimate through PXRF. All of the above. So this is the correct answer for this question. Now, question number 10. From Planck's law, it can be concluded that, so we know that according to Planck's law, E is equal to NV mu and or C is equal to lambda mu. So E is equal to NH by C lambda. Okay. So E is directly proportional to mu and E is directly proportional to 1 over lambda. So energy is proportional to the frequency. Okay, energy is inversely proportional to the frequency. Energy is proportional to the wavelength. So we know that energy is proportional to the wavelength, that is correct, and energy is proportional to the frequency. So inversely proportional to the wavelength, and energy is proportional to the frequency. So B and C both are correct. So option D is correct for this. Question number 11. What should be the property of good estimator? So we know that good estimator according to the blue, right? So it should minimize the variance. That is correct. It should be linear and unbiased. All of the above are correct. Because a good estimator should not only be close to the true value on average, but also consistent across the sample and that have a minimum variance. So lower the variance ensures the more precise estimates. While linear estimator is expressed as a linear combination of observed values, so linearity helps in simplifying statistical interference and ensures the stable and interpretable models in many classical methods. While it's unbiased is that is an estimator said to be unbiased if it is expected values are a true parameter, and this ensures on an average estimator hits the target parameter value. So all of the above is the correct answer. Question number 12. Visible near infrared spectroscopy works in which range? We know that visible near infrared spectroscopy works around 350 to 2500 nanometer range. So correct answer is option A. Okay, so as we can discuss or we can see from this image also, right? That uh, uh, visible rays are in range of 400 to 700 nanometer, while visible near infrared range is up to 400 to or 350 to 2500 nanometer. Okay. And 700 to 25,000 nanometer, that is extend beyond the near infrared, and that lies in mid infrared and far infrared region, while 2500 to 25 triple zero nanometer, that only includes mid infrared and far infrared regions. In the GIS model, data is organized by layers, coverage, or themes. Layers are comprised of mainly how many data types. So we know that in the GIS data model, we have a two data types. So the two data types, one is a vector and second is raster. So vector, it's generally represented by points, lines, and polygons. So points like the home of something or hospital, schools, that we are represented as the points. While line is river, then also like roads, highways, that we are representing as a lines. While polygons, that is lakes, then certain small water bodies, also certain grounds that we can consider in the polygon. While in case of raster data, so raster data we are generally representing through grids, and that grids have a cells in that, and that cell have a specific size. Okay, and that cell represent the single value of that continuous data. So generally for rainfall data, temperature data, or certain other environmental parameters, we are using raster data. Okay. Okay. While so correct answer for this question is 2, right? Option D. Question number 14. Vector type of GIS data model is used for discrete data and is represented as points, lines, polygons, and all of the above. So we know that vector data in GIS model that we are used for discrete data representation. Okay, and that we are generally representing through points, lines, and polygons. So all of these are correct. As you can see, these are the points, these are the lines of roads, and these are the polygons. Question Question number 15. In GIS, accuracy of database is described by parameters like positional accuracy, consistency, and completeness. What does positional accuracy show? So we know that let's first quickly read the options. So positional accuracy, if features characteristics in the database match those in a real world, okay, are all real world instances of features present in database, how close are the features to real world location, and the size of smallest feature able to recognize. If feature characteristics, so this defines so first one, the feature characteristic in the database match those in real world, that is attribute accuracy. Okay, while all real world instances of features present in database, that is completeness. Okay, and how close are features to real world are related to the positional accuracy. So correct answer is option C. While the size of smallest feature able to recognize, that is related to the resolution. Okay, resolution means what is the size, or that if we are presenting in the raster data. Okay, so raster data have a certain resolution, and raster data, as I described in last slide, that it have divided or represented through grid lines, and these grids have various cells, and the cell size have certain resolution. For example, like 5 meter by 5 meter, 10 meter by 10 meter, or 90 meter by 90 meter. Okay, so that is the resolution of data. So correct answer for positional accuracy. So it shows how close are the features to their real world locations. Question number 16. What are the major components and functions of geographic information system? So major components and function of GIS is only software and maps, hardware. No, it is not correct. Hardware, people, but no geographic data. That is also incorrect. Software, hardware, people, and geographic information system, that all combines to the geographic information system. So correct answer is option C. Question number 17. Which of the following is not a direct component of GIS system architecture? That is query input, geographic database, climate monitoring system, or output display and remote or reporting. So we know that query input, that is a critical input methods in GIS system where users interact with the data using specific question or search condition to retrieve relevant spatial information. Then geographic database. So this is the core storage unit in GIS, and it contains spatial attribute data which are analyzed and processed for decision making. While climate monitoring system, that may produce special data, it does not standard internal component of GIS architecture. So this is the incorrect. Okay, that is the not direct component of GIS. While output and display reporting is the essential function for GIS, where processed information is visualized in maps, graphs, and reports for interpretation and action. You can see here this is GIS architecture. So it have a various user base. Okay, I describe here. Question number 18. Which of the following statements correctly distinguish vector and raster data in GIS? So vector is used for continuous data, raster is used for discrete data. This is incorrect because vector we are generally using for discrete data representation, while raster that we are using for continuous data. Raster uses coordinates, vector uses grids. So this is again incorrect because raster uses grids and vector uses coordinates to represent. Then vector represents discrete features and raster is used for continuous surface. This is the correct, I think. Raster and vector models are interchangeable for all GIS operations. So this is not right. So option C is correct. Question number 19. Which of the following is not a segment of a global positioning system? That is GPS. Space segment, control segment, user segment, or atmospheric segment. Right. So in all of this, we know that GPS have a control segment, user segment, as well as atmospheric segment, but it does not have space segment. Okay, it consists of constellation of GPS satellites orbiting to Earth, continuously transmitting signals used for positioning. Correct answer is option. Sorry, they are saying not the segment. So okay, space is a segment. In the GPS, control segment is also there, user segment is also there, but atmospheric segment is no. There is a no role of in GPS. Right. Correct answer is option D. Question number 20. Which of the following correctly describe the GPS control segment in the working of GPS system? So control segment, it includes satellite that orbit Earth and transit signals. Okay, it is the user device that receives GPS signals. No, that is not. It monitors satellites health and update satellite data. That's also, I think, incorrect. It measures atmospheric delays affecting signal accuracy. So we know that. Uh, so it is space segment generally include satellite that orbit the Earth and transmit the signals. So correct answer is option C. That is, it monitors satellite uh, health and update satellite data. Okay, that is control segment characteristics. And first one is related to space segment, and second one is related to the user segment. Question number 21. Which of the following is not a major source of GPS error? Satellite or clock error, that is the major. Then receiver or clock bias, that is also a major error. Atmospheric distortion, that is also major source of error due to rain, buildings, vegetation present in the nearby users. While terrain elevation is not the major source of error. So correct answer is option B. What is the cause of multipath errors in GPS system? So we know that multipath errors, so signal bouncing of surface before reaching the receivers. This is the correct answer because multipath errors occurs when GPS signal reflects off building, trees or ground before reaching the receivers. These reflected signals arrive later than direct ones, causing confusion and positional inaccuracy. While sudden power loss in satellite, so power loss in satellite would disrupt the signal transition entirely, not just cause the signal delay. Okay, it is not typically source of multipath. Receiver battery degradation. So battery issues may affect device uptime, but they have no role in signal reflection or multipath uh, propagation. And finally, lack of satellite visibility. While poor satellite visibility can lead to weak or inaccurate signals, multipath error specially refers to single reflections, not the absence of signals. So correct answer is option A. That is signals bouncing off surface before it reaches to the receiver. Question number 23. Which of the following components are involved in understanding the variability in geostatistical model? So that is deterministic process, stochastic process, and pureness. So I think we have covered already this question. So correct answer is option D. Deterministic, stochastic, and pureness all are related to this. Okay. Question number 24. Which of the following is statistical probability based spatial prediction model? Fusion polygon, inward distant interpolation, kriging, or spline. So we know that among these, kriging is a statistical spatial prediction model. So correct answer is option C. While Thyssen polygon, that is a mathematical or empirical model that divides space based on a proximity to nearest sample point. It doesn't rely on statistical assumption on probabilities. While in IDW, that is another empirical method that estimates values at unsampled location based on nearby samples point, giving more weight to closer points and less weight to further point or uh, higher distance point. Well, kriging is the statistical geostatistical method, and that does not only predicts unknown value but also provide estimate to prediction error, and it considers both distance and degree of variation between known data points. Well, splines are empirical again, and that creates smooth surface through sample points, and they are deterministic and that don't incorporate probabilistic distribution uncertainties. So from this figure, you can see that this IDWD predicted values. Okay, so that shows uh, unsampled map values, unsampled location values, as well as related statistical errors. Question number 25. Which of the following is valid model used in variogram fitting for spatial data analysis? Circular, logarithmic, polynomial, or Fourier? Circular, this is one of the authorized model for variogram fitting. Okay. It assumes a specific spatial correlation structure and used to model how similarity between points changes with distance. While logarithmic, that is not standard model used in variogram fitting, although logarithmic models are used in other fields they are don't satisfy required condition. Polynomial, that is may be used in a regression or trend analysis but not directly used in variogram models. While Fourier series are used in a signal processing and time series analysis, not in variogram models. So correct answer is option A, that is circular. Question number 26. Which of the following is an advantage of diffuse reflectance spectroscopy in soil analysis? Diffuse reflectance spectroscopy requires it is a complex and time consuming. No, it is a non-invasive and portable. Okay, it is high recurring and operational cost. It cannot analyze nutrient parameters. So this incorrect. This also incorrect. And among these two, that non-invasive and portable. So DRS is non-destructive technique and highly portable. Okay, making it ideal for field-based without testing the sample. And DRS is not uh, involve high cost. It is a cost-effective technique, right? So correct answer is option B. Next question, question number 27. So that is what is the primary function of spectron panel in reflectance spectroscopy? So we know that to absorb infrared radiation, so panel is designed for high reflectance, not for uh, absorption. Okay, so this is incorrect. So again, uh, the spectral panel is used as a wide reflectance with 99% reflectance. Calibrates the spectrometer and removes ambient and humidity effects for accurate spectral readings. That is correct. And it blocks ambient light. So purpose of panel is exactly the opposite, to reduce the ambient temperature and humidity difference. Okay. It is not increasing reflectance errors. And to act, it is acting as a sensor for detecting soil moisture directly. So while it helps to improve readings related to soil properties, but it does not sense the soil moisture directly. So correct answer is option, right? The primary function of spectron panel is to serve as wide reference and optimize spectrometer. Question number 28. In the context of given data mining process, what is the correct sequence of steps? So in the data mining process, correct sequence of steps is database, right? As this database, then we are uh, from the database we are selecting data, then doing certain spectral processing, then transforming it, and doing some modelings and rule information finally. So correct answer is option C. Question number 29. Which of the following is not limitation of total petroleum hydrocarbon, that is TPH, measurement by gas chromatography as mentioned in the image? So it is a time consuming. So this is a valid limitation as I mentioned in the image, right? The GC based TPH measurement takes considerable amount of time due to its procedural complexity. Highly portable. So this, GC is not portable, right? Because it's a comprehensive device. It have a various component in the analysis. It requires certain gases, gas cylinder, then heavy instrument, then desktop. So that all cannot be portable. So correct answer is option. And it is a labor intensive, obviously, because to extract certain samples we require some skilled labors or skilled task force, and for its analysis that instrument also requires specific staff. It requires sample pre-treatment. That is also correct. So correct answer, incorrect answer is option B. Question number 30. Which of the following is not advantage of PXRF as highlighted in the image? So we know that it is a non-destructive analysis. That is correct. Require chemical reagents for scanning. That is incorrect. Field portability, that is portable in nature, and multi-element analysis, that is also we can do it like soil pH, soil cationic capacity, soil organic matter, its macronutrients, heavy metal, etc. So correct answer is option B. Question number 31. Which of the following best describes DSM? That is digital soil mapping. So we know that manual method for field-based soil classification, that is incorrect. Computer-aided mapping of soil and its property. So correct answer is option B. It is not traditional technique, right? And it is not an analog method for soil texture and assessment. Digital soil mapping is computer-aided mapping for soil and its properties. Question number 32. Why is pre-processing of soil data important in digital soil mapping? Because all soil study samples, only the topsoil, because soil attributes are measured consistently across the locations, because soil data are collected at varying depths and attribute combinations, because all soils are measured at fixed bedrock depth. So we know that some studies may focus on topsoil, but others go to the bedrock. So digital soil mapping needs to be handled this variability. And because of soil attributes are measured consistently across the location, so the issue of digital soil mapping inconsistency that normally uh, um, or it is not uniform, and in how and where soil attributes are measured. So this is the incorrect option. And final, the answer is because of soil data are collected at varying depths and attribute combination. Right. So correct answer for this last question is this option C. Okay. So with this, let me quickly recap the session that what we have done. So in this session, we have focused on the GIS, that is Geographical Information System, and GPS, that is Global Positioning System, and its role in soil science and technology. Then certain statistical methods like kriging, that is a statistical technique, while certain methods like empirical and uh, mathematical equations like IDWD, these are polygons, as a geostatistics to compute any uh, unknown location environmental parameter. Then we have also discussed on basic of diffuse reflector spectroscopy and XP or PXRF, right? That instrument that we are generally using in the field, that is cost effective, that is rapid in nature, to measure multiple elements like soil, certain soil properties, like heavy metals, macro and micronutrients, soil pH, soil electric conductivity, etc. And then finally, we have solved certain questions that it is related to this week number 11. And now we are at the end. So if you have any query from this, you can ask. We have a few minutes left. Okay. So if you do not have any query, let's wrap up this session here. And I hope you are enjoying this session. And let me again emphasize that I am whatever content I am covering, that I am uploading on this YouTube channel. So I request you to watch out these sessions that are very important for your upcoming NPTEL examinations. And you can also access all the materials in the form of PDF from this Google Drive. And I kindly request you to provide your valuable feedback through this Google link, and that will help me to improve my teaching skills. So, thank you so much for joining.